Okay, hi everybody. So we'll get started with some exercises on tangent and normal lines. So the first problem, we'll just have to find the equations of the tangent and normal lines to the curves at the following points. Okay, I missed writing normal lines to the curve y equal f of x at the following points. Great. Now before we begin, let us remind ourselves of the tangent line. Of course, in class we have seen this a lot, and the motivation behind this as the instantaneous rate of change, and how we define this as the limit when x approaches a of the ratio f of x minus f of a over x minus a. Now, suppose f is a differentiable function at a number a. An equation of the tangent line at the point, or the tangent line at the point uh, to y equal f of x at the point where x equal a is just the line through a f of a with slope f prime of a. So an equation of this line is hence y is equal f prime of a times x minus a plus f of a. Of course, there are many ways that you can derive these equations, but at the end, this is one of the equation you should get. Okay, basically, if I know a point on the line, which is a f of a, and I know the slope, which is f prime of a, then I can find an equation of this line. Okay, great. Now let us move on to the normal line. The normal line to y equal f of x at a f of a is the line through that point that is perpendicular to the tangent line at a f of a. Now in particular, if f prime of a is non-zero, then the normal line has slope minus 1 over f prime of a. Why is that? Because if I have two lines and who have non-zero slopes that are perpendicular, then the product of the slopes is minus 1, right? So if the slope of the tangent line is f prime of a and is non-zero, then the slope of the normal line is a negative reciprocal of that number, so it's minus 1 over f prime of a. And now I know a point on the normal line, which is a f of a. So with that info, I can derive the equation of the normal line. Okay, provided f prime of a is non-zero. And here we have a small, here I have made a small graph. This is the line, this is a curve. I think I drew y equal x squared. In green, you can see the tangent line at 1, 1. And in yellow, you can see the normal line at 1, 1. Both lines are perpendicular, as you can see, right? You can see that. Both lines are perpendicular. I tried my best to draw it. And both are through 1, 1. And you can see that the normal line is in yellow, and the tangent line is in green, and the curve is in blue. Okay, great, awesome. So let us try to do some exercises. The exercises we have we wanted to do. Great, so find the tangent line to the curve y is equal secant x plus tangent x at the point where x is equal to pi. Let me just add that's fine. Oh, we have space here. So if y is equal secant of x plus tangent of x at the point where x is equal to pi. So y prime in that case, what is the derivative of secant? It's secant tangent, right? Well, first of all, let's find y of pi, right? Y of pi is secant of pi plus tangent of pi. Tangent of pi is 0, and secant of pi is 1 over cosine pi, right? This is 1 over cosine pi plus tangent pi. So cosine pi is minus 1, so y of pi is minus 1. Okay, let me maybe... Okay, y of pi is minus 1. Now what is y prime? in order to find the tangent line, I need to find y prime. So y prime, what's the derivative of secant? This is secant x tan x. And the derivative of tangent is secant squared x. So y prime of pi is equal to, well, secant pi is -1, tangent pi is 0, so this is 0, plus secant squared pi. Secant squared pi is -1 squared, right? So this is just 1. Okay, so what is the equation of the tangent line? Tangent line at pi -1. What is that? This is y is equal y prime of pi. Well, I mean, let's just replace it immediately. That's fine. 1 times x minus pi minus 1. So what do you get? You get just x minus pi minus 1. Okay, now let's look at the normal line at pi minus 1. This is y. What's the equation of the normal line? Well, this is -1 over 1, right? Times x minus pi minus 1. So this is just minus x plus pi minus 1. Okay, so this is the first function. Now let us look at the second function. X plus 2 over 2x plus 1 at the point where x is equal to 1. Y is equal to x plus 2 over 2x plus 1 at the point where x is equal to 1. Okay, I mean, maybe here okay. So let f of x be x plus 2 over 2x plus 1. What is f of 1? Of course, the x value is 1. The y value will be, it's 3 over 2 plus, it's 3 over 3, which is 1, right? Yep. Okay, what is f prime of x here? F prime of x, what is that equal to? It's equal, well, I use the quotient rule. Derivative of the numerator is 1. Derivative of the denominator is times the denominator minus the derivative of the denominator, which is 2, times x plus 2 over the denominator squared. So f prime of x, what is that equal to? It's equal to 1 minus 4, right? This is clear, so it's minus 3 over 2x plus 1 squared. Okay, so the tangent line, what is f prime of 1 here? F prime of 1 is minus 3 over 3 squared, which is minus 1/3, which is different than 0, of course. So the tangent line, what is the equation of the tangent line? It's y is equal f prime of 1 times x minus 1 plus f of 1. We computed f of 1, which is 1. So what is that? F prime of 1 is minus 1/3, right? We see that, times x minus 1 plus f of 1 is 1. So we can simplify that, minus 1/3 x plus 1/3 plus 1 plus 4/3. Now the normal line, this is just 1. Why? Well, f prime of 1 is non-zero. So the normal line has slope minus 1 over f prime of 1 times x minus 1 plus f of 1. So minus 1 over 1/3, this is minus 3, right? You see that? Oh, no, this is just 3, right? Times x minus 1 plus 1. So what do you get? You get 3x and 3x minus 3 plus 1. So this is 3x minus 2. Okay, so this is an equation of the normal line at, at 1, 1, at 1, 1, right? F of 1 is 1. Okay, great. We have one more. What is that? X plus sine x at the point where x is equal to pi. Y is equal, this is C, x plus sine x at the point where x is equal to pi. Now, well, if x is pi, what is the y value? Y of pi is equal to what? Is just pi plus sine pi, which is just pi. Okay, now let me differentiate y. dy by dx. I mean, I'm trying to change notations to get you exposed to different notations you have seen in class. So dy by dx, what is that? This is 1 plus the derivative of sine is cos. Now dy by dx at x is equal to pi. What is that equal to? This is just 1 plus cos pi, which is 0. So the slope of the tangent line is 0. The tangent line has slope 0, which means it's horizontal. Right? We have seen that in class, right? So if the tangent line has slope 0, if dy by dx at x equal pi is 0, then I cannot apply this formula for the normal line, right? Because in order to apply this formula, I need to assume that the derivative at that point at pi is non-zero. But I mean, if it's 0, it's not the end of the world. It may be easier. Because if the tangent line is horizontal, so first of all, what is the tangent line? It's just 0 times x minus pi plus pi, which is pi. Now, this is the tangent line. Now recall, what is the normal line? Let us get back to the definition of the normal line. It's the line perpendicular. Normal line is perpendicular to y is equal to pi and passes through the point pi, right? So what can we say about this? It's a vertical line that passes through the point pi, and hence the normal line is just the line x is equal to pi. Okay, now let's move on to other exercises. This one. Okay, so this is very important here. If the tangent line is horizontal, then the normal line is vertical. Okay, let's move on. Okay, now let's move on to this exercise. So let f of pi over 4 is 5 and f prime of pi over 4 is 2. We need to find an equation of the tangent line to the curve y is equal f of x over 10x at the point where x is equal pi over 4. So let me actually add a new page in order to do this question. So if f of pi, let's rewrite this here, f of pi over 4 is equal f prime pi over 4 is equal, I need the tangent line let's add normal line as well, and normal line to y is equal to f of x over 10x at the point where x is equal pi over 4. I forgot to take these values, 5 and 2. Okay, great. Now, first of all, if y is equal f of x over 10x, at pi over 4, the y value at x is equal pi over 4 is just f of pi over 4 over tangent pi over 4. Now we know that tangent pi over 4 is 1, so this is just 5 over 1, which is just 5. Okay, now what do I need here? I need dy by dx. What is dy by dx? By the quotient rule, this is just f prime of x tan of x. The derivative of tan of x is secant squared x times f of x over tan squared x. So dy by dx at pi over 4, what is that equal to? I have to compute the slope, so I need the derivative. F prime of pi over 4. What is f prime of pi over 4? This is 2. Tangent pi over 4 is 1. Secant squared pi over 4. What is that? So I know that cosine pi over 4 is 1 over root 2. Cos squared pi over 4 is 1 half. So secant squared pi over 4 is just 1 over 1 half, which is just 2. So minus 2. F of pi over 4 is 5. Divided by tangent squared pi over 4. Tangent pi over 4 is 1, so it's 1 squared. So what do we get here? We get 2 minus 10, so this is just minus 8. So the tangent line, this is just y, is equal at minus 8 times x minus pi over 4 plus f of pi over 4, well, not f pi over 4, but f of pi over 4 over tangent pi over 4, right? Y at pi over 4, which is 5. Okay, let's see if, I don't think we can write it a bit nicer, but that's fine. Well, plus 2 pi, right, plus 5. Now the normal line, what's the equation of the normal line? Well, the slope of the tangent line is negative 8, which is non-zero. So the normal line, it's minus 1 over, has slope minus 1 over minus 8, which is 1 over 8 times x minus pi over 4 plus 5. This is just 1 over 8x minus pi over 32 plus 5. Okay, so here I'm not looking really at y equal f of x, but I'm looking at y is equal f of x over tan x. Okay. We'll move on. Now find all the points on the curve y is equal x cubed plus 6x squared minus 9x plus 2, where the tangent line is horizontal. Should have had more space here. Okay, points. This is question 3. Points on y is equal. Well, let's see where the tangent line is horizontal. Sorry about that. I need to x cubed plus 6x squared plus 9 minus 9x minus 9x x cubed plus 6x squared minus 9x plus 2, I think. Is it plus 2 or minus 2? Well, it matters a bit. Where the tangent line is horizontal. Okay, so what is y prime? So tangent line is horizontal. It means that the slope is 0. So what do I have to compute? I have to compute y prime and set it equal to 0. So it's 3x squared plus 12x minus 9 is equal to 0. Well, what happens here? I can simplify by 3. It's x squared plus 4x minus 3 is equal to 0. We can factor that. Let's see if we can factor. Yeah, I think it would have been better if we had a plus 9 maybe. Let's see. X squared, like 3x squared, you simplify. Yeah, 16. No, it doesn't. I think we should have had a plus 9. Would have been way better, I think. Sorry about that. So let's fix this. plus 9x, I think, would have been good. So yeah, I fixed that. Now this is way easier now. This is just x plus 1 times x plus 3 is equal to 0. So this is the point x is equal minus 1 or x is equal to negative 3. So if x is equal to negative 1, what is y equal to? It's minus 1 plus 6 minus 9 plus 2. So it's minus 10 plus 8, so it's minus 2. So at the point minus 1, minus 2. And if x is minus 3, y is, so negative 3 cubed is minus 27, plus 6 times 9, this is 54, plus 9 times minus 3, which is minus 27, plus 2, so this is just 2. This is just the point minus 3, 2. Okay, so let's double check. Minus 3 cubed is minus 27, plus 6 times 9, yeah, 54, plus 9 times minus 3, yeah, no, looks good. Okay, so at these points, the tangent line is horizontal. Okay, whenever you ask for a point, you need to give an x value and a y value. Okay, great. We have 2 more questions. Or we have some space, actually. Oh, that's good. So here we'll have to find all the points on the curve y is equal to root x, where the normal line is parallel to the line y plus 6x is equal to 5. This is question 4. Points on y is equal root x, where the normal line is parallel to y plus 6x is equal to 5. Let's double check. Is that what we had? Yes, sure. Yep. Okay. Now, the slope of the normal line, you know that 2 parallel lines have the same slope. What is the slope of this line? I have to write this line as minus 6x plus 5. So the slope of the normal line must be equal to 2 minus 6, because 2 parallel lines have the same slope or are both vertical. Now here, the normal line must have slope equal to minus 6. Now what is the slope of the normal line? So first of all, I have to compute the derivative. dy by dx is just the derivative of x is, we can see that this is 1 over 2 root x. I mean, we can do this by looking at y is x to the 1/2. So dy by dx is 1/2 x to the negative 1/2, right? 1/2 minus 1. So dy by dx is kind of the slope of the tangent line. Now, if I need the slope of the normal line, all I have to do is just minus 1 over dy by dx. What is that equal to? This is just minus 2 root x. So I need minus 2 root x to be equal to minus 6, right? This is the slope of the normal line. In general, right? I mean, so here I have root x is equal to 3, and x is equal to 9. And if x is equal to 9, then y is equal to 3, right? So the point, so the normal line to y is equal to root x has slope minus 6 at 9, 3. Okay, so at x equal 9 and y is equal to 3. Okay, now let us move on to the last question. So show that there are 2 lines through the point 2 minus 5 that are tangent to the curve y is equal x squared and find the tangency points. Here I've used the GeoGebra to draw a picture. Of course, the picture may not be, well, it might not be very easy to draw by hand, but you may get an idea. So this is the point 2 minus 5. What is this? Well, no, I don't want blue. Anyways, this is the point 2 minus 5. It's here. And you can see that there are two tangent lines to the parabola y is equal x squared. So really what I need, I mean, if you want to see, you know, it's a bit difficult, but this is one tangency point and this is one tangency point. So really what we have to do is that to find these 2 points, we need to find a way to find these 2 points. Now this is not very easy to think of, but let us start by finding a way of setting up this problem. Okay. Now the idea here is that first we write down the equation or an equation of the tangent line to y equal x squared, sorry, at the point where x is equal to a. So really at the point a squared. Okay, this is the point. Okay, so what is this? This is going to be our strategy. So really what I'm looking for is finding a. We need to find a. Using the fact that 2 minus 5 belongs to this tangent line. Now it's very easy to see that this tangent line has equation y is equal to 2a times x minus a plus a squared. So it's y is equal to 2ax minus 2a squared plus a squared gives minus a squared. So this is the tangent line to y is equal x squared at a squared. Now, if 2 minus 5 belongs to this tangent line, what can we say? We can say that minus 5 is equal to 2a times 2 minus a squared, right? This means that the coordinates 2 and minus 5 satisfy the equation of the line. So what can we say here? Minus 5 is equal to 4a minus a squared. Then what do we get here? We get that, well, let's put everything on one side. A squared minus 4a. Is that good? Yeah. Minus 5 is equal to 0. Now, can we factor this? We can. So this is just a plus 1 times a minus 5. So a is equal to 0. So a is equal to minus 1. Or a is equal to 5. So the points where the tangent line passes through 2 minus 5 are just the points where a is equal minus 1 and 5. So minus 1 or 5. So the tangency points are minus 1. What's the corresponding y value? 1, right? Minus 1 squared. And 5 squared, which is 25. Now, if we look at this here, well, this is the first tangency point, y is equal to 5. And this is the second tangency point. Sorry, x is equal to 5. and x is equal to -1. Okay, so this is a question that that you may have to think of, but it's a good type of questions. Okay, so please practice this, folks. I'll also assign you many problems from the book where you're gonna have to do things like that. But the most important idea is to understand how to attack this question, how to tackle such questions. Is first by, if we're looking for tangency points, we write down an equation at an arbitrary point, AF of A, of the tangent line, and then we use the info that we are given, that 2 minus 5 belongs to this tangent line, and so the x value of and the y value of this point satisfy the equation of the tangent line, right? This is what we did. This is the step. And then we used it to solve for the tangency points. Okay, everybody. I hope this was helpful. Of course, this wasn't too easy, but yeah, so practice this and thank you.